this is Christine Halsey, and today we're going to look at measuring series current and voltage drops. We'll be using both Multisim and the breadboard. The first step is solving for the total resistance. In this case, we have 1K, 2.2K, 3.3K, and 1K resistors for a total of 7.5 kiloohms. We can use that total resistance to solve for our total current. Given the voltage and the total resistance, we divide the 10 volt source by the 7.5 kiloohm total resistance, and that gives us a series current of 1.3 milliamps. So anywhere in this series that we measure the current, we should measure 1.3 milliamps. The voltages across the resistors, however, are different. Each resistor is going to have its own individual voltage drop. So in this case, for V1, it's I times that resistor value, R1. So we have 1.3 milliamps times 1K, which gives us 1.3 volts. For R2, the voltage would be I times that resistor value, which is 2.2K, and that gave us 2.93 volts. And R3 for V3 was a 3.3K, and then V4 is a 1K again, so it's at 1.3. Now if you add all these up together, it comes up to 9.93 volts, and if you were like me, you'd be like, okay, where did I lose it? You lost it in the rounding. So if we carry these numbers out to their full extent, then we'll see less loss in that addition. And that's Kirchhoff's voltage law. Okay, you can see here we're set up to measure the current. In the series circuit, the meter is turned to A for current, and I'm getting 1.33 milliamps right on the nose. Okay, so the first thing I'm going to do here on the breadboard is set up my series circuit, making sure that I'm connecting the resistors in the same columns instead of running them side by side. Side by side is an open. Right, then I do not have the resistance connected to the power supply yet. That would affect my total resistance reading. So here I just have the leads connected to the ends of the resistors, and the resistors are sitting on the breadboard. I don't even have them pushed in there. You can if you want. And my total resistance is coming up to 7.45 kiloohms. Or 4.6, real good, within tolerance. Now I'm making my connections up here for ground and power and running them down to my breadboard. Typically I would use a longer red wire and have this coming around, but I keep forgetting to grab my wire when I'm at school. Alright, then I have the 4 resistors hooked up here, and I'm going to connect them to power. Okay, I've turned my meter on for voltage. It comes up to AC. I have to select to measure DC. I've connected my 2 leads to complete the connections in my circuit. I'm going to turn on my trainer and measure my total voltage. And it's coming in right at 4.99 volts. Alright, to measure each resistor, I'm going to move my ground lead here across that resistor to measure that voltage drop. My apologies, we're at 10 volts here, so I'm going to go to the plus 18 and ground on the adjustable side. I've gone back to measure my total voltage. I'm going to turn on the unit, and then I'll have to adjust the knob. It's pretty, it was set for 9 volts. And I'm going to use my knob and turn it up and get it as close to 10 volts as I can. Oh, that's close. I'll probably stop there. That's about as good as I get. So I'm using the knob here to adjust the plus 18. And I'm running my power from the plus 18 and my ground here. Now I can measure each individual voltage drop. There's my supply. I'll come first, hook up across the first 1K. Which I think we had calculated 1.33, and we have 1.342. Very close. Alright. I've moved my leads to the next resistor. Notice how the red stays more towards positive and the ground stays more towards the ground of the circuit as I go around. And this one was 2.93, measuring 2.4849. Now remember, my supply is a little high. It's at 10.05, so mine will come out just a tad bit high. Okay, here's across the 3.3K. Notice again how the red lead's staying closer to power and the ground lead, the black lead, stays more towards ground. And measuring right at 4.42 volts. Okay, and here we are across the last 1K resistor, and I'm measuring 1.34 volts. Now I want to measure the current in the circuit, so the first thing I'm going to do is turn off my trainer. I'm going to disconnect my lead here on the meter. I'm going to go ahead and flip my meter over to measure milliamps. And then I'm going to take my leads, and somewhere in my circuit I have to make a break. So I'm going to break right here at the power supply. Once I do that, I'm going to grab another wire here just to give me something else to clip onto. And I'll have the end of the resistor that I pulled up and the wire here. Now this wire is going more toward ground, so I'm going to connect my ground lead, trying, to that wire because it's closer to ground. And then I'm going to connect my red lead to the resistor and fill in that open that I created with the meter. Alright, now I'm going to plug my red lead into the milliamp and turn my power on. Wow, look at that. 1.34 milliamps. I couldn't be prouder. That's so close. It's scary. Hope you've enjoyed measuring series current, which we're doing now. Complete the open and the individual voltage drops that we did first.